This talk is about multi-input, multi-output control systems and why we need to know more about these systems. And this is also a part of the LIME project. I hope that it will be helpful to you. Let's review what we mean by multi-input, multi-output system. As you see, when a system has several inputs and several outputs, we call it multi-input, multi-output systems. And there are many systems in industry that inherit this characteristic. But why do we need to know about multi-input, multi-output systems? We will further discuss this issue. This is just a photo of our very recent visit to one of the petrochemical and oil industries. And when we are dealing with real industries, we need to know more about multi-input, multi-output system and their characteristic. But to see some example, let's look at this simple tank system. Here we have two loops, two control loops, a level controller by this cold stream and a hot temperature controller, TC, by a hot stream. So while we have two separate loops, level control by this cold stream and temperature control by this hot stream, any change in these controllers or any action by the controllers will affect or will disturb the other control loop. So they interact. We call the system has interactions. So here there are also some disturbances. So any improvement to the level control loop will affect the temperature control. Any improvement in the temperature control will affect the level control. So how should we deal with this problem? But let's see other example. Distillation columns are also very famous in industry. On the left hand side, you will see two schematic diagrams of distillation column. This one is a continuous fractional distillation column, and this is another one is a continuous binary distillation column. And on top you will see the vacuum column of an oil refinery, and this is also a real again a double effect distillation plant. So distillation columns are among the systems which are multi-input, multi-outputs, which have multi-input, multi-outputs, and we should deal with this concept. But this is also another picture that show you when you go to industry and there are some distributed control system installed there, you will see the schematic of all the process and all the pumps, all the valve and all the things over there. You can easily see the situation, the measurement, the current conditions, and then you have to decide about the control loops, about the control configuration, etc. But which are the typical questions about multi-input, multi-output system? The first question is, how many inputs are we dealing with? How many outputs are we dealing with? Which input can influence which output? Or assuming that all inputs may influence all outputs, which input is more effective in influencing a particular output? So which input should be used to control which output? And the other concept is the zero and poles of multi-input, multi-output system. How do we define them? Are they the same as how we define the single input, single output systems? Pole zeros of single input, single output system? No, there are some differences. So we will explain about this in the lectures. What kind of complication do we face for multi-input, multi-output system that we didn't face where we were using single input, single output systems? Which are the tools or methods for control of multi-input, multi-output system? Are we still using PID control, or there are also better way? So these are the issues that you will be learn about multi-input, multi-output system.